Day 53, Density Lab. In this lab, you're going to be looking at the problem, does a mineral's density affect its hardness? In other words, which is going to be more hard, a really dense object or not so dense? Is it true that if you get a more dense mineral, that it's also going to be more hard? Number one, define density. That is defined by the math equation of mass divided by volume. So this fraction kind of defines density. Define hardness. Number two, it's the ability to be scratched. And we do that on a scale from 1 to 10 called Mohs scale. If it is easily scratched, it's going to have a 1. And if it's almost impossible to scratch, it's going to be a 10. So with that in mind, let's make your own hypothesis. We want you to read this sentence and then choose the choice that completes your hypothesis. What is your idea? From your own experiences, what do you think is the answer? Number three, as a mineral's density increases, its hardness will, do you think it's A, increases, or do you think it's B, decreases?
Let's check in.
Procedure. Let's first figure out the hardness of the material. And the material that I'm going to be looking at is this material right here. It is a white mineral, and it looks just like a normal rock. You can't see through it at all. It's what I would call cloudy white. So the first procedure it says here is try to scratch the mineral with your fingernail. If it does not scratch, then it's going to be harder than 2.5, and we're going to keep on testing. However, if we can scratch it, then we know that the hardness of the mineral is less than 2.5, and we will stop there and we'll record that in the data table. So here we go. Here's that, and I'm going to try to scratch it. And sure enough, look at that. I get little flakes coming off. So that means that the mineral here is not as hard as my fingernail. My fingernail has a hardness of 2.5. So we're going to write off to the side here that sample A is less than 2.5 in hardness. It's less than the hardness of my fingernail. Write that off to the side on your packet. Okay, next we have sample B. Sample B is this white clear material. It's almost looking like glass, like you could see through it a little bit. Let's try to find the hardness of this. I first try to scratch it with my fingernail, and I'm not making any scratches on this at all. So I look at this chart here. Number 4, try to scratch the mineral with your fingernail. No scratch. It's something harder than 2.5. We don't know how much harder it is, so we got to keep on testing. So that means we're going to go down to the next step. If it did not scratch with a fingernail, try the copper penny. So here's a penny. I'm going to try to find a nice smooth spot on this mineral and then scratch it. And I can see that, yes, indeed, I did make a little scratch on the crystal here. So number 5, if it did scratch, write 2.5 to 3.5. So off to the side here, sample B, 2.5 to 3.5. We'll transfer this information to the data table later on. Okay, the next mineral is going to be this black thing. It's called magnetite. First of all, try to scratch it with your fingernail. And no, it's not going to scratch. Secondly, try to scratch with the penny. And no, it does not scratch. Next, we're going to try to scratch it with the glass. So you have a glass sheet here. and it does not scratch. Next, you try a steel nail, and that does scratch a little bit. I can see a scratch there. And so for line number 7, I'm going to put sample C. It's something between 5.5 and 6.5. I know that it's harder than 5.5 because it did not scratch with the glass. I know that it's less than 6.5 because it did scratch with the nail. Okay, so those are our 3 samples. Next, we're going to determine the density. And I've made sure that all of your samples do fit into the graduated cylinders. And so we're going to be using the displacement method like we learned in the first chapter of the class. You're going to add about 150 milliliters to a graduated cylinder. So zooming in here, about 150. It's not exactly. Here's 150 and the water level is up here. So I have to count. Each one of these lines is 2 milliliters. So there's 150, 152, 154, 156, 158. It's really close to 160. So on my paper, I'm going to write down here that the low level of the water is 160. Next, it says, carefully add the mineral sample A to the graduated cylinder. So there's my sample A, and I'm going to add it. Water splashes a little bit, but the water level now went up. Here's 170, 172, 174, 176. So on my paper, I'm going to write 176 as the high level of the water. Number 11, subtract the high level minus the low level. So that's the 176 minus 160. That's going to be 16. So that is the volume of the rock that we put in. Excuse me, not rock, mineral. 16 milliliters. And we're going to repeat these steps now for samples B and C. So here is the graduated cylinder for my next trial. Again, it's just about 150, not exactly. It doesn't need to be exact. Let's count up. Here's 150, 152, 154, 156. We're going to call it 156 as the low level. And now let's put in the mineral and figure out the high level. Now I had an awful lot of splashing on the last trial, so I'm going to tilt it and slide the mineral in so that it's less splashing. And now the water level has gone up. This is 160 here, 162, 164. So the high level is 164. On my paper, I'm going to write that down here. And then subtract, and we get 8 milliliters for sample B. Now let's do sample C. Getting a new graduated cylinder. The water level here it's more than 170. Here's 172. We're going to call that 172 for the original low level for sample C. 172. And now I'm going to slide in the rock sample, the mineral sample, and see how high it goes up. Again, tilting so that we don't splash a lot. Now it goes up Here's the 170 mark. This will be 180, 182. The high water level is 182, and we subtract and we get 10 milliliters as the volume of that sample. Okay, now I am going to stop the video, and I'm going to go over and get, oh, no, I'm going to go over and grab the triple beam balance. I'll be back in just a second. Okay, next we have to use the triple beam balance here. Voila. And we'll get the mass of each one of these samples. So, triple beam balance. We got to get our sample out of the graduated cylinder. So we're going to dump that out. And there it is. We put our sample on the triple beam, and we want to slide these back and forth so that this arrow lines up with the 0 mark. So 40 is not enough. It's tilted high. So go to 50, and that's too much. It's sunk down. So it's somewhere between 40 and 50. So I put that at 40, and I slide this over until it balances. And it's 47.5. So I write down on my sheet here, number 15, using triple beam balance, measure the mass of each sample. Sample A is 47.5. Now let's do sample B, the clear mineral, the one that looks sort of like an ice cube. Balancing this. 40 is too much. It's sunk down. Go to 30. That's too much. 20, too much. 10. 10 is not enough. So I slide this over. And it balances at 17. So I can write down on my paper here, sample B is 17 grams. Now we do sample C, the black magnetite. There it is on my triple beam balance. And my 17 that I had there before is not enough. It's way up high. So let's figure out where it should go. Let's do 30. 30 is not enough. 40, not enough. 50, too much. So it's somewhere between 40 and 50. 45, 46, 47. 47 looks just about right. Amazing that it's so close to sample A. So on my paper here, sample C is 47.0 grams. Okay, number 16, write the equation for density. Density is equal to mass divided by volume. Number 17, using your data, calculate each mineral sample's density and record it in the table. Okay, so for sample A, we want mass divided by volume. The mass is 47.5, and the volume we had up here, the volume for A was 16. So I get my calculator and I divide those things. 47.5, 47.5 divided by 16, 2.96. For sample B, the mass for sample B, we just said was 17 grams. And the volume for B up here, we said was 8. So 17 divided by 8. 17 divided by 8, 2.125. I'm just going to put down 2.1. And then sample C. The mass was 47.0, and the volume up here was 10. That was in line 13. It shows us that the mass, or the volume, was 10. So I divide that and I get 4.7. Here's the calculator. 47.0 divided by 10 gets me 4.7. So those are all the densities. Analysis, number 18. Plot your data on the given grid. So on the second page that I've given you have this grid here. And we're going to plot the density and the hardness of each one of these three minerals. So for sample A, we had a density of 2.96, and we also had a hardness of less than 2.5. For mineral B, we had a density of 2.1 and a hardness that was 2.5 to 3.5. For mineral C, we had a density of 4.7 and a hardness of 5.5 to 6.5. So let's use that information to make this plot. For part A, sample A, density of 2.9. So we go along this scale here, that's the density. 2.9 is going to be really close to 3, right about in there. And then we're going to go up to a hardness of less than 2.5. That's this first line right here. So I'm going to make a data point right there. That's for A. Let's label it A right there. Circle it. Then sample B, the density is 2.1. That's going to be a little bit closer right there, 2.1. And we're going to go up to a hardness of 2.5 to 3.5. That's right here. Make a dot there, label it B, circle it. And then sample C, we had a density of 4.7. That's going to be right about here. And a hardness of 5.5 to 6.5. That's up this high. Looking at the y-axis, it says 5.5 to 6.5. So make a dot there. Label it C, circle it. Okay, now that we've done those three samples, I want you to get a third sample and figure out its density and hardness and plot it on this line or on this graph as well. You'll label it as sample D. Go ahead and fill out this table with all of your information that you've gotten throughout the whole lab. And on the front side, fill out the hypothesis. That's the same sentence that we had before, where you circled either option A or B. rewrite this as one sentence with only your one answer as the hypothesis. Write down all the materials that we used. For the procedure, you look over the different things that we've done to find the hardness. You're going to be talking about the penny and your fingernail and the nail and the glass plate and such. Write down the steps that you did there. And then write down the steps to find the density right here. Now I've written down 8 steps. You might be able to write it down with fewer than 8. You do not need to have all of those lines filled out. Whatever you need, you use. You can condense it as much as you can. And at the very end, fill out these sentences here as a conclusion. And then you'll turn in this one piece of paper with all the students' names in the top corner there. One paper for all students working in your lab group. Thank you very much.